Great Horn Email Security protects organizations from advanced threats such as impersonations, credential theft, and zero-day attacks. With Great Horn, you will detect and block more phishing threats from reaching users, reduce risk by providing employees with in-the-moment education, and quickly remove dangerous emails from inboxes in just 2 clicks. Great Horn protects your organization before, during, and after an email attack. Schedule a demo by visiting securityweekly.com/Greathorn. When it comes to modernizing identity, Active Directory just makes everything harder, from managing access for contractors and departing employees to securing cloud apps and on-prem systems. Your company deserves better. Choose Okta, the modern identity platform that securely connects anyone that touches your organization to any technology they want to use. Okta reduces AD vulnerabilities, secures not only employees but contractors and customers, simplifies domain consolidation, and reduces your attack surface. To learn more, visit securityweekly.com/Okta. Security can't solve crucial problems when they have to wade through thousands of alerts a day. With ServiceNow, you can easily prioritize and respond to your most crucial business threats. That way you can go from overwhelmed to under control. ServiceNow brings security, risk, and IT together on one platform. Learn more at securityweekly.com/ServiceNow. Welcome back, everyone, to Enterprise Security Weekly. I think I doubled up the announcements in the previous segment, so I'm good for this one, which is awesome because we can dig right into it. Our guest for this segment is Ward Cobleigh. He's the Senior Product Manager at VIAVI Solutions and understands the balancing act between network ops and security that IT pros are facing today. Ward, welcome to the show.
Hey, thank you very much. I'm excited to be here.
I love the topic because it really, when you were describing this to me and we were talking about like how we would title it and what we're going to talk about, it really took me back to the days when I worked at the university and I was pulling security information and tidbits from all over the place, right? I'd get some NetFlow, I'd get some full packet capture, I'd look at the host logs and syslog, right? And you titled this Threat Detection, the Network Scavenger Hunt. And that's exactly what I was doing at university. Was every day I was going on a new scavenger hunt, which is really fun, by the way. And I do miss, those days of doing that because you never knew what you were going to find, right? And sometimes I'd find, compromised system in some weird department. I had to put like booties on my feet to like go into the room and stuff like that, right? So it was fun. It really was like a physical scavenger hunt at the end of the day. Fast forward today, thankfully we have better tools than we did, 15 plus years ago. And I think that's going to be much of the topic today is that process and some of the new tools that we have.
Yeah, exactly.
So I know you have some slides and you want to kick off and remind our listeners a little bit about what VIAVI Solutions does, a little bit about your position in the market, and dig into some of the, network scavenger hunting.
Yeah, absolutely. And hopefully you've got my image there. So for some of your listeners who may not be familiar with VIAVI, we may be the billion-dollar company that they've never heard of, but odds are that you're at least familiar with some of our history, some of our heritage, where we came from, if you will. Companies like Wandel and Golterman, founded back in 1932 when I was just a teenager, or perhaps you recall WaveTech, TTC, Acterna, JDSU, or Network Instruments. This is really where our business unit within VIAVI came from. And our instruments, as you can see, are deployed in over 100,000 data centers globally. What we're really best known for is high-speed, long-term data collection and retention. And this is a core capability that's allowed us to become experts in understanding network and application performance and being able to translate that into end user experience. But what we're going to be focused on today is...
I just want to add a little color there, because again, it reminds me of my days at the university, and I know some may be thinking, well, they didn't start out as a security company. But when I was analyzing stuff at the university, to both directions, right, I would find stuff, I'm like, this isn't a security, I don't think this is a security thing, but it's a network or a performance thing, right? Like it's an architecture thing. You've got these routes being advertised here. They shouldn't be, right? It's a performance thing. This host is sending out way more traffic than anyone else. I don't think it's compromised, but something's going on, right? And I was observing all of that, to steal the kind of name of the product, right? Observing that while I was looking for security incidents. So it's very much all the same thing. And then others in the university, after I would point that stuff out, would come to me and say, hey, we're having this weird problem. Can you like look at all your tools and like tell us what's happened? We don't think it's a security event, but we're having some kind of issue and we need some visibility into that. And so this all ties together.
Yeah, absolutely. If you think about what is the ultimate source of truth and visibility when it comes to a security event, it's the packets, right?
Mm-hmm.
There may be a lot of things that bad guys can do to cover their tracks, but they're not going to take the packets off the wire. That evidence is always going to be there.
Exactly.
Our history was looking at those same packets more from a performance perspective, but now we've really seen the need as we're talking to our customers and NetOps and SecOps, the lines are blurring, the walls are coming down, is to say, hey, let's not just focus on the performance side of this. Let's go use that same data set, that same high fidelity data to go get better at providing information about suspicious and malicious behaviors. And that's really what we're going to talk about today.
Yeah, and Ward, and one point here, right? Performance impact could have a indicator into security. Security could impact performance, right? There is a balance here when performance and security are both in the mix. And again, you're collecting a lot of the same data.
Yeah.
The use case might be different, but the use cases can also influence each other to identify either a performance or a security impact.
And what's nice too is it doesn't matter what's on either end, right? I think a lot of times we get too focused on what's on either end. And I remember helping with issues they were having on the mainframe. Now, I had no experience with mainframes, right? But I could look at the packets and give them valuable information, right? And that was, to me, really cool.
Nice. Yeah, I mean, what's the first thing that people ask when there's suddenly an application or a server that takes a big performance hit? You want to rule out, could this be a security issue? Could this be a threat? Could this be, bad guys?
Right.
And so, again, having that raw source of information, you can quickly get to that domain isolation. Is this, some unwanted traffic? Is this suspicious traffic? Or is this just higher volume than normal?
Right. Sweet.
So I had a little, with your kind indulgence, I had a little idea of how we might set the stage or briefly illustrate what I hope will be a key takeaway from our conversation. You can see the map here. I'm from the Washington, D.C. area, and there's a lot of interesting and fairly obvious things that are visible to anyone who walks down the National Mall. You see the Capitol building, you see the Lincoln Memorial, you see the Smithsonian Institution, you see the White House, right? Those things are all very obvious to you as you stroll through the heart of our city. But at this point, I have to put you and your listeners on high nerd alert. Many years ago, someone told me about this thing called geocaching, and I ran out and I bought this little Garmin Gecko. It was a handheld GPS because my uber cool BlackBerry Pearl phone didn't have accessible GPS. And when I got my little GPS fired up, I discovered this. I discovered that right there in the midst of those big monuments and museums were these little hidden treasure troves, dozens of hidden caches that were right there for the taking if you knew where to look. And so the point I'm trying to make with this is that sometimes there's interesting things all around you. You just have to know to look. You have to know where to look. You have to know how to look. You have to know what you're looking for, and you have to know why you're looking in the first place. And so what I was thinking we would talk about next would be some of those treasure troves that are hidden around the network, and what they might be and what we might find if we go digging there.
Yeah, and without modern tooling, you may be asking yourself those questions mid-investigation. Wait, what am I looking for again? Why am I looking? How am I this far down the rabbit hole and I forgot what I was looking for, right?
Right. Well, and part of the challenge becomes there's so many places to look. There's so many places where those hidden gems, as I refer to them, might be found. I just listed a few here, right? Sometimes people think of, well, there's obvious data sources. I can go get the packets in the data center. I can maybe go get flow data from the edge routers. But honestly, there's a lot of different data sources out there, even following a single path. If you just look at this very basic diagram, for instance, where could we get information along this path? Well, if I kind of work left to right, let's say that I'm my applications either live in the cloud or maybe they're hybrid. Parts of them are in the cloud, public or private. Within the cloud, there are sources of information. It could be VPC flow logs, for instance, or it could be that I'm using the native capabilities of my cloud provider to tap or mirror, right? So there's flow data potentially, there's packet data potentially, log data potentially. You could deploy third-party tools in the cloud like Ixia Cloud Lens, for instance, that can give you wired data or enriched flow records. And that's just, at the far left side of this simple illustration. But as you move to the right, obviously routers can provide you with all kinds of information. Your firewall can give you a unique perspective. Switches, even all the way down to the endpoint, the server, the user workstation, whatever the case may be, there's data that can be gathered all along the path. But that might beg the question, well, if you gathered all that up, if you collected all of that, wouldn't it just be duplicated information? If all these devices are essentially seeing the same traffic, isn't that just going to be a duplicate? And don't we live in a world where we want to intelligently deduplicate and not just duplicate? And that's valid, right? I'm not suggesting that people just go around and collect every single source of data they can find. It makes me think of my kids go around and they turn on every light in the house just because they can.
Right.
Just not necessarily what I want them to do. But what we're suggesting is to look at, in this case, a path end to end and find out, well, where are the more valuable data sources? Where can I get some unique perspective? And ask yourself a philosophical question. Is there really such a thing as a duplicate flow? Because really, every device has its own unique perspective. And every device has its own unique form of data that they export. And so in some cases, you might want data from multiple points along a path, if that makes sense.
And what I found, Ward, is that as an analyst, regardless whether it was when I was at the university or today, right, when I look at an issue or problem, a potential security incident, I have in my mind what the story might be, right? And I want to find data to either prove my story wrong or support my story. And each piece of data that you pull along, this chain or wherever your chain lives in the cloud, on-premise, or some combination thereof, it should support the narrative that you're putting together or allow you to piece together the narrative so you can make the determination, is this a security event or not? And the more sources you can, again, pulling from everything all the time is difficult, right? But strategically pulling to support the narrative, I think, is really where allows the analyst to be most effective.
I love that choice of wording, a narrative, because each one of these things has its own story to tell, right? So there was, if you don't mind, I was actually going to illustrate this with an actual demo. We saw a path, and there were 5 devices along a path. In this case, all of those devices could give us flow data, for instance. Every one of those points along the path is capable of producing some kind of conversation flow, whether it's traditional net flow, IPFix, or some proprietary flow flavor. Why might you choose one over the other? Well, this is a view from our Observer Apex product. It's a threat map that is populated by flow data. And what we're looking for here are 3 general categories of behaviors. So we're doing SYN forensics. In other words, we're looking at the SYN packets and we're looking for suspicious patterns, suspicious behaviors that would point to a network scan or a port scan taking place. We're looking for evidence that a blacklisted IP address is involved in a conversation. And we're also looking for what we call profile exceptions. Simple explanation. In most environments, there are different categories of devices that behave predictably, whether it's medical equipment, ATMs, point of sale systems, CCTV devices that normally would only talk to a small number of destinations on a small number of ports. We'll describe those in our system. And if they start doing something that's out of character, we'll tell you about it. But what I wanted to do was illustrate the ability to go from a very high level view with data that's typically thought of as being useful for characterizing bandwidth utilization and traffic volumes, right down to a deep dive forensic view. So let me shift our focus here for a second. We're going to go look at what I would consider to be just a typical view of the world provided by NetFlow, right? Counts and amounts, top host protocols, conversations, interfaces. This is what a lot of people think of when they think of flow data. But keep our illustration in mind, right? That path. Let's see what the firewall could tell us using flow data that perhaps the other devices in the path couldn't tell us. And I'm going to ask for information about a specific IP address. Now, this specific IP address has been seen. There have been flows that the firewall has observed that have this IP address. And you see the blue line is the outgoing flows. The green line are the incoming responses. And we can start expanding on this, right? So this particular device I can see has been attempting to communicate with 56 unique destinations using TCP port 135. But in the reverse direction, coming back, nothing. Why? Well, let's go dive into the forensic data. And if I change my view to take advantage of what the firewall can tell me, we're going to find out exactly why that was. So here's every one of the flows from my 224.107 address to 25.5.6.7.8.9, and the firewall's telling me what it's doing with it. It's blocking it because of an access control list. And so basically, this device is telling me, I saw this traffic, I did my job. And so, we went very quickly from just this high-level view of the universe down to a very detailed view of what one device along the path was seeing and doing with the traffic. And hopefully that kind of illustrates the point that we were making here in this diagram.
Yeah, and in that scenario, the network team can rejoice because they've done their job, right? But the security team maybe has an incident to look into because likely that machine's infected with something, right?
Yeah, exactly. He's doing something bad. We want to go stop that. But the good news is we put the countermeasures in place to prevent this thing from escalating.
And what's interesting, sorry, Matt, I was just going to say what's interesting is earlier in the week we covered, actually yesterday, we covered SYN flooding, which is still happening today. And some major providers were attacked because a lot of network providers weren't doing the proper egress filtering, which I thought was standard. And when you go to any enterprise, right, and the network team looks at you and they're like, yeah, we're doing proper egress filtering, then you test it, or you have a tool like this and you go look and you're like, well, in this one segment, you're really not. And that's how on the internet we're able to do SYN flooding like that because, reflection attacks, I should say, because people aren't doing proper egress filtering, largely because they don't have the visibility that Ward just described.
Yeah, and so again, whether your data source is packets, whether it's flow, everywhere along the path, you're going to get a different view of the world. And sometimes it's advantageous to do the traditional monitoring of the edge using, the router conversation data. But sometimes we really want to dig a little deeper, hence our theme, right? The scavenger hunt, this treasure hunt, digging into these different sources of data to see what makes them uniquely valuable compared to the data that the neighboring device might be able to provide.
Sure. Matt?
Yeah, I was just going to say that means you don't have the allow any rule at the bottom of your firewall rule list, but it does help you validate that the rules you think you have implemented are actually working in this particular case.
Yeah, exactly right. Exactly right. It's one thing to set it up and say, I got it right. It's another thing to have the proof.
Right.
Yeah. So I had another interesting example here, if you guys don't mind. We talked about that whole path and how left to right you can get different sources of information. Let's go far right. What could we get from the end node or endpoint perspective? There's probably a lot of people listening that are Cisco AnyConnect client users, and before everyone goes and gets their torches and pitchforks, that I've got a screen up here, version 4.2 that's out of support. I use this particular image for a reason. It's because it illustrates the fact that the network visibility module is loaded. Why did Cisco create the network visibility module? Well, for the reasons described here on the slide, is more and more administrators have less and less visibility into what's going on with unmanaged devices. Well, what if you have the ability to collect information from those devices and report on that, not just at a high level, but in detail? And, forgive me for this super small font here, but I've kind of highlighted the things that I wanted to talk to. This particular module can give me, courtesy of flow records, information about the user, the manufacturer of the device, the operating system, the version, the applications they're accessing, the FQDNs they're talking to. And so now, from the endpoint's perspective, I know that it's Bob, and I know what sites Bob's going to, and I know what kind of laptop Bob is using. I've got all that. I'm not, and this is in flow, right? But I'm not going
Yeah.
to get that from the edge router. I'm not going to get that from somewhere else in the path. I've got to go to the endpoint to get it.
So, or you said that's in flow data, and I think many of us, myself included, think of flow data as layer 3, right? It's just what's in the IP header traversing the network. But there's been lots of extensions to flow data.
Yeah, absolutely. And this is probably one of the things we talk about the most, is the fact that you started off in 1996 with this really basic form of telemetry where 5 to 7 fields made up a unique flow record. And it was really just, host protocols conversations. That was all you could get out of it. But since 1996, we have had a couple things happen. One is we had all these different variations of flow come out. We came out with JFlow, CFlow-D, sampled flow. We had all these different flavors, right? And then the IETF stepped in and said, hey, we've got a Tower of Babel situation. We're going to rectify. We're going to create a common language that everyone can speak. And the concept of IPFix was born. Well, IPFix is out there. It does provide a standard. It also provides templates that allow us to go from 5 to 7 pieces of information to 500 to 700 pieces of information. The problem is not every vendor is choosing to use it. Some have kind of stuck by their guns and their proprietary flow flavors. Some are using it, but they're not populating all the fields that they could populate. So I'll give you a simple example. An SD-WAN forwarding device can tell you why it changed a route, but not every SD-WAN vendor populates that information in their flow record. This takes us back to the theme. As you're digging for treasures, as you're on the scavenger hunt, you have to understand not only what a device can output in terms of the format that it will output in, but then you have to go look and see what is it actually capable of sending me. But to your point, NetFlow can sure do a whole lot now that it couldn't do a decade ago.
And I would imagine a very lightweight way to get this data. I mean, this is not using a heavy agent. I mean, this is just picking this up in the flow record, which would be pretty lightweight when it came to collecting this kind of data and leveraging it.
Yeah, you hit a couple key points there. One is we're not talking about massive volumes of data, unless we're talking about collecting every flow record from every flow-enabled device in a big enterprise. Then yes, it can get voluminous. But the other point you alluded to there, the data source is already there. It's deployed. It exists. We're not talking about you have to drop an agent on every device that you want to collect flow from. Those devices that we looked at along our path, the majority of them already have this capability. All you have to do is either turn it on or point it to a collector. Your firewall is probably just sitting there going, I got a lot I could tell you. You just need to tell me where you want me to put the information. So yeah, flow is there. It's ubiquitous. It's under every rock that you peek under. But you just have to know it's there, and you have to know why you're going to go take the time to look at it.
Yeah, and there's certainly pros and cons, and we've debated them on the shows over the years between flow data and full packet captures, right? And there's certainly, and the struggle is real, right, with full packet capture as you get into words you're alluding to, larger enterprise networks. Collecting full packets can be difficult, right? Because you've got 10 gigabit backbones. You've got a lot of engineering challenges to overcome and relationships to form with your network team, right? Oh, there you go. You have a slide on this, right?
Yeah, you go.
So yeah, there's pro. Obviously, you get better information. You had, I think, what was a great analogy on that, Ward.
Yeah. So here's the thing we look at is flow can do a lot, especially these enriched flow records that we were talking about that now have all kinds of fantastic information. But the analogy that we sometimes like to use is imagine that you had a CCTV security system. Here's what flow does. Flow tells you someone came in the building. They tell you which entrance they used. And they tell you it looks like they carried a bunch of stuff out, and it tells you what exit they used, right? So that's good to know. Somebody got in, they took a bunch of stuff, and they left. But what the wire data gives you, what the packets give you, is it shows you every single step that they took. It shows you everything they put in the box. What did they take from you? What did they exfiltrate? It allows you to recreate the event step by step, packet by packet. There are times when there is absolutely no substitute for having that wired data. And those times are, as we've said, if you really want to do a recreation of an event, if you really want to understand exfiltration details, you're going to want the packets to do that. Or if you're more on the network operations side of things and you really want to do an in-depth analysis of end user experience, Flow is better at telling you about the things that are traveling across your network than it is the performance of the devices at either end. Flow can do some performance analysis, but it's not what it was designed for, and it's not a key area of strength in most deployments.
But it can be used as a very effective alert mechanism to look for things that are out of the norm.
Absolutely. Absolutely. Because, I gave you the example of creating a device profile. Your users are a little less predictable, perhaps, than some of the devices on your network, but there's whole classes of devices on your network that should behave a certain way, very predictably. And if they start behaving in another way, if your printer starts acting like a web server, that might be something you'd want to know about. And so Flow is fantastic for that. If you understand how a particular device should function, the conversations that it should have, if you know what story it should be telling as it's talking to the world, and then all of a sudden it starts talking in a completely different language to a completely different audience, you probably have a problem on your hands. And Flow is a fantastic way to find out about that.
Fantastic. Ward, anything else on this topic or updates to the product recently?
Yeah, so I guess just one other thing that I would highlight, I was going to touch on the fact that look at some of the devices you already have in your environment. Packet brokers, packets in the name, but packet brokers can be a great way of getting flow data. They can tell you all kinds of interesting things. Gigamon has their own variation called GigaSmart NetFlow module. Ixia, which I happen to highlight here, can tell you things about the geographic location of your devices, the performance of your location. Some of these packet brokers are actually even doing their own threat analysis. They're looking at behaviors that look suspicious, and they're sending you descriptions of those behaviors in a flow record. And so they've already done the analysis for you, and they're willing to hand it to you if you simply know how to collect the data. And so that's really kind of what our focus is, right? Is we realize that there's all these different sources of information out there that you can dig through and you can find great information from. What we're trying to do is always be on the lookout for the best sources of information and not just go grab, raw flows or raw packets. Try to enrich these data sources however we can, whether it's taking a simple flow record and going out and augmenting that with MAC layer details, physical port connectivity information, user authentication information, information that might be available from the cloud. And so now, instead of just telling you that this IP address talked to this IP address on this port, I can tell you it was this device attached to this switch port on this MAC address with this logged in user talking to this other device at the other end. And by the way, the behavior looks suspicious. Really, that's what we're trying to do, is leverage all those different data sources, bring all of that wealth, all those little hidden treasures together into a format that allows you to proactively manage performance or security. But obviously, as we've discovered today, Flow is a great way to look for suspicious behaviors and to get ahead of them.
Fantastic. Well, Ward, thank you so much for appearing on Enterprise Security Weekly. If our listeners would like to learn more, you can go to securityweekly.com/VIAVI. That's VIAVI. Ward, again, thank you so much.
My pleasure.
And with that, we will round out the show. Thank you, everyone, for listening and watching. We'll see you next time.